Possible.
Hey,
How are you today?
good. How are you, Brad?
I am well. I am excited about what we're going to show people today. I think it's going to be
Yeah, this is going to
really
be
cool.
cool, I think.
Yeah, definitely, definitely. Um, so one of the things that you and I, or I'm working on, is the idea of. Let me share screen here. The idea that there are a lot of folks in the research community doing really cool models with prompting, with context, with memory, with um, LLMs that they're using, et cetera. And all of the time they're doing this, they're having to do it um, in Python with
Using
500 different scripts.
MCP.
Yep, exactly. And so I wanted to quickly talk about this. Actually, happens to be, I guess it's not showing on screen. Can you see that?
I can see it.
Okay, cool. I didn't know if it immediately went for me or I had to show it. Anyway, this is a model called SwarmSys. Was put together by a bunch of researchers, most of them out of Hong Kong and New York. And the reason I reached out to these folks to try to get them to build their research within Kilroy is because it's an entire model of improving agent outcomes using swarms. And when you look at kind of how they built this thing, the fact that they're utilizing probably 5 or 6 different Python libraries and scripts and piecing it all together to get their research, they probably spent a huge percentage of their time just building out the functions to actually test their hypothesis. Well, if they built it utilizing our capabilities and then integrated the algorithm in as a module, then they would be able to significantly speed up the research they're doing and tweak and make changes to the way they're doing research if they were using Kilroy. So,
I hadn't even thought about it till you mentioned it, but one of the things that's always a problem is being able to replicate somebody's research or duplicate the work that they're doing or try to have theirs as a starting point. And it's always a pain. You've got to set up the same environment. I've got to get the same tooling. I've got to know the same programming languages and stuff that they're using. And that's problematic. It's a little more standardized in the computer science world, but I spent a lot of time off in the human physiology world at University of Texas. And that's a lot harder to set up the same lab conditions and all that stuff. And it just dawned on me that if you set up some pipelines and some logic, add a few customized workflow tools and a couple of Kilroy apps, that's just shareable data. I can give you the entire pipeline. I can give you all the tooling, and I can give you everything that you need to duplicate what I just did in a little zip file.
Yeah. And then you've got peer review processes made incredibly easy and fast, right? Whereas, any other way of doing it's a manual, difficult process to set up. So it makes
on my machine.
Yeah. Yeah. So, and that's the beauty of Kilroy, right? Is that when you're using Kilroy, it doesn't matter what operating system you're running on or what's installed on your computer, because
or even where your LLMs are.
Exactly, because Kilroy is running as a layer and it's not going to require all of the same configurations. So it's really cool. This research is actually great. I'll put it in the show notes. But the idea was that they created these agentic swarms that allowed for agents to have better outcomes because, as we've talked about, they had multiple agents working on multiple tasks and then find the best solution from those tasks. It's a lot more detailed than that, but that's the general gist of it. So something else that came out this week was this platform called Glyph. Also, another more research work done. And the idea was that they could take really long context length, which is something that happens with all of these LLM and agent systems, is you end up with this massive context. And we have one way of solving that with Kilroy, of breaking context into smaller pieces through multiple agents within a swarm that can self-generate and that can be stored. And we're going to actually show an example of storing context and changing context on the fly which leads to agent self-programming. But this was pretty cool because what they found was when they took this massive context files, these big giant text files, they could convert those text files into images and then use a vision language model to interpret and read the images. And they resulted in better performance, higher compression, less tokens used for those that are using centralized LLMs. It just improved everything dramatically to take this, in this case, a novel of 180,000 words, and put it all in image files so that they can be read by the LLM. And they built infrastructure around that. But again, something that Kilroy can solve in terms of breaking context down, but also something that could be implemented in Kilroy for those instances when a really long context window is needed to process some amount of.
Just to be clear, Brad, were they making images of the text, or were they making images out of the text?
They were making images of the text.
So it was just like scanned images, but that was better performing than tokenized text.
Yeah, it dramatically reduced up the token requirements. I don't know if it's
That's
because
insane.
yeah, I don't know if it's because the visual VLM performs better than the text LLM, but for some reason it could process it much faster.
Wow. Oh,
yeah,
it's
kind of cool though. Yeah, absolutely, absolutely. And they built a custom model for doing it, so it's in Hugging Face. It's something we could implement as a visual LM in Kilroy. So
as soon as we can do pictures, right?
Exactly.
So do you want to talk about the toy I made this morning?
Yeah, man, because I love that thing. Let me.
Well, I don't want to call it's not really a toy, but it stems out of. Let me give you a little bit of background. So for the last couple of years, we had an ongoing collaboration project with some folks in the Bitcoin community to try to use Kilroy to set up a decentralized exchange for perpetual swaps for Bitcoin. And that involves all the things that a centralized exchange has, right? Order book and pricing and bid ask, order fulfillment, and sort of a consensus about what's going on with your peers in this network. So it was to be decentralized. It was a decentralized order book. It was decentralized order processing, and it was decentralized order fulfillment, because with perps, there's all this rebalancing and a bunch of other stuff that has to go on. And so we spent a lot of time doing a lot of extra code inside of Kilroy to support the whole idea of perp contracts and how to keep the contracts balanced and how to do the bid ask pricing and the order book work. And it just kind of got overcome by events. Right. And it dawned on me this morning, because I was watching the price of Bitcoin going sideways and saying, man, I wish there was a way to hedge this. And why didn't we have that stupid decentralized exchange? I thought, well, we have all the pieces to do that now with our swarms and the collaborating agents in the swarm. All the stuff that we were building with custom code 2 years ago is now drag and drop in the agent builder, in the pipeline builder, with the stuff that we have now. So I thought, well, what's a good example of how to do sort of consensus document management, right? The order book is a shared document, right? It's sort of a virtual spreadsheet or a virtual database that everybody participates in with their orders. And this is going way back. So back in the 80s, 90s, early days of Unix, pre-Linux even, on the internet, people used to have what was called a .plan file. It was a little text file that lived in the top level of your login directory, and you kept information in it, if you used it, about what you were working on, what was your plan for the day. And you could query people's plan files by using a plan command and their host name and username on that machine, and it would tell you what their plan was. So I thought, well, what if we re-implemented that in Kilroy as a way for a bunch of people collaborating in a swarm to provide some shared information on demand? Same thing as an order book, right? What's in your order book? What's your current price for the swap? What, all of the details that need to be shared amongst everybody in the swarm to make sure you have consensus. Let's just do that with plans. So I sat down this morning at 8 o'clock, and by 8:30 we had swarmed plans for work groups working in Kilroy. And what does that mean? I can sit down and Brad, why don't you pop open the screen for Kilroy if you can do
Yep.
that. This is kind of a scary view. Really, all you care about is this text area on the left-hand side. These are all just views into the various agents that make up the pipeline, and I'll show the pipeline in a minute. But the idea was I should be able to get online and I don't know. Let's see what we can do with the pipeline. I can type help. It'll tell us, okay, pipeline's got these commands on it that you can use. Help, set some plan text, and see what the plans are on the network. So right now, I just started this one from scratch, and I shouldn't have any plans set, and it'll tell me that. But the really cool thing, and you can't see this on my screen, but we're going to switch screens back and forth in a minute, is Brad is running this same pipeline on his machine. And so when I ask for plans, not only is it going to go fetch what my plan is for the day, but it's going to ask all the other participants in the swarm, of which there's only one today, Brad, what their plans are, and their agents are going to return it, and it's all going to be aggregated here in this text window. So let's see what everybody's plans are. I haven't set a plan yet, and it knows that, and Brad's LLM is starting up so it can tell me what his plans are. There it goes. And Brad's plans are biz dev calls and make some contacts and finish our tokenomics document. So let me set my plan. And you can, if you're creative about it, use Markdown in here. All right, so I've set my plan, and it's in the system now. And if Brad on Brad's machine decides, hey, what's Chuck up to? He can do the /plans command on his machine. My machine is going to respond. Hands are off the keyboard, and watch the blinky lights on the right-hand side of this screen as Brad's request to the swarm comes in, and my LLMs wake up and figure out what I'm working on and tell Brad. There they go. So it's offered up what my plan is, and then Brad returns, here's his plan too. So anybody that asks what a plan is, everybody gets an update.
Right. That's awesome. I love this. Okay. Because this opens the door to 100 other things you could do with this.
Any collaborative shared knowledge, right? We could be Bitcoin price oracles, right? And somebody asks in this forum, what's your price for Bitcoin right now? And you get 10 different answers, and you can do whatever math you want to do to figure out what a fair market price is for that coin or equity or any other asset that you want to work together in a swarm to trade.
Yeah, we could also set all kinds of keywords in the app itself to store knowledge and data and information, contacts. You could build a CRM around this. I mean, there's a million things conceptually.
The storage. I mean, I think we're doing something that I've never seen anybody else do with an LLM, and it is a disturbing thing to force them into doing. But we're actually using the system prompt in the context of these LLMs to be variable storage for the rest of the pipeline.
Yeah.
What does that mean, right? And so normally your system prompt is setting a personality or telling it how to behave or what kind of output format that you want. But in this case, the system prompts are really simple. And I want to show you, I'll show you what the system prompt is right now for this LLM agent. This is kind of a gross way to see it. We'll go look at it in the pipeline editor in a second, but in the live running agent, you are an agent that holds a single piece of data, the user's plan. Whenever you see input from the user, respond with only the following text. And the text is set to, I'm working on new Kilroy startup code, this cool plan app. Well, that's the stuff I just entered in the text window, right? And the LLM's system prompt is set to that. So if I do another set command, all right, and just change my system prompt now. If you go back and look at that agent's system prompt now, it's the stuff that I just typed.
Yeah.
Right. So on the fly, we are changing the configuration of the LLMs based on what's going on in the swarm. Right. This is a simple example. I type something in the screen and it generates and sets the system prompt. But then later on, anybody can ask that LLM, because we keep no context for this LLM. It's a zero context discussion that goes on. I can say, what's the value of Chuck's plan? And it puts out, I am demoing Kilroy plans. Brad said, zoom the window there.
Yeah.
Yeah. And go ahead. Describe
all I was going to say is that the beauty of this is that not only can you customize or on the fly agents and or users by entering context or information can automatically customize what an LLM has stored with it. I mean, an agent has stored with it, but we can have agents dynamically create more of these agents that are storing other types of information. So theoretically, you could take this thing to a level of generating functionality that you want in a collaborative or productivity or project management or CRM app, and storing it in each of these agents and keeping track of it and dividing it down to the level of companies or people or tasks or whatever. And it's pretty much the sky's the limit. Another thing that we talked about on the last episode that this makes this even more dynamic and powerful is, we're not going to show this today, but you can integrate this with a Telegram group. You could integrate this into, as a bot in a Telegram group, into Discord, into Slack, into whatever chat app you might want to integrate into Kilroy, so that all of your team can work wherever they choose to work. They won't have to be in the Kilroy app if you just want people to access and send information and interact with the agents and update data.
I mean, it can listen to your email. It could listen to, it could be integrated with any other interface format, right? You could have custom web pages that talk directly to Kilroy.
Yeah, you could have a UI around it that populates and says, oh, I see a tag A, B, and C, so I'm going to put them over here. You could have a UI that self-generates. Yeah, you could have anything. And so for me, that actually really solves kind of one of the problems in group work, especially in the crypto space, where everyone has their own tools, their own ways of doing things, their own way of tracking their tasks, whatever. This allows you to interact with Kilroy however you choose, and to be able to see the information you want to see any way you want to see it, right? The engine will just give you what you're looking for. So that to me is really powerful.
Right. So in this example, we're using an LLM to actually store the data and return the answer to the swarm of what's my plan. I could have some other calendaring or to-do list app or something else that's integrated into Kilroy through a different block. And when that command comes in, what's your plan? It goes and hits that application instead. This one just happened to be all self-contained. But let me, this is kind of a scary picture, but it's really not. Let me describe what we're doing so people understand, because this idea of using the system context of the LLM as variable storage is huge, because for decently capable models, you could give it a JSON object to remember, right? And that JSON object could have 50 fields in it, right? So you want to keep the hands that were dealt and the bets that were made in an online poker game. You just got one JSON object that the LLM has to manage, right?
Yeah,
you want to keep an order book for 50 people who are participating in a swarm, and one guy's going to keep the master order book. It's just one data structure that you stash into the context of one LLM, and everybody can ask for it through the swarm. So in this case, a lot of this stuff up here is about processing those commands that you saw me type, the help command, the set command, and things that aren't commands. If you just type some gibberish that it doesn't understand, it gives you an error message. And if we go back over here and look, I can do that. If I just type junk in here, it says, hey, these are the commands that you do. Don't type junk. And that's just not a command path. And so the premise here is that I type some stuff up here in the interactive screen, and it goes into a private swarm where we figure out locally what to do with it. Was it a command that I can handle locally? Am I telling the user some help? Am I giving the user an updated system prompt? Or is it a message that needs to go out to the swarm i.e. go list the plans for everybody out there in the swarm and get their results back. That's the plans command over here, /plans, and it goes around this way, and it launders that into a different command, /list plans, so that goes to the swarm and there's no confusion. All the listeners in the swarm see a list plans command come in, and they go up and say, hey, AI, you just got asked a question. Well, this AI system prompt, as we saw, is nothing but you're holding on to a single piece of data. Whenever you see input from the user, respond with only whatever the plan is, right? And this is the default system prompt, which says I haven't set a plan yet. But if I use the set command and follow this path through the swarm, we get over here to a place where the thing that I typed /set whatever my plan is goes into this box called set prompts. And set prompts job is to change the system prompt in whatever LLM it's pointed at. And it's going to change the system prompt to the same system prompt that was there before. You're an agent that holds a single piece of data that's the user's plan, blah, blah, blah. And here's the data that they just said that is their new plan. Pass that through to the LLM agent that's here. And what happens is that replaces this value with what came in over the red wire. And now the next time somebody asks for my plan in the swarm, they're going to get the updated plan. So this is a really twisted application of LLMs insofar as it doesn't keep anything but one piece of context data, and that context data is whatever the current value is for the variable that it's responsible for. Other agents can ask for that data. Other users can ask for that data. The data can be set. It can be changed. It can be deleted. It acts just like a variable in a programming language. And we said this before, Brad, this is a Turing complete programming language with this weird picture stuff, because we have conditions and branches, and we have loops, and we have halting conditions, and we have the ability to change variables. So literally anything that you could come up with in any other programming language, you can do in here, given the limits of these gray blocks. These are the external commands of things that Kilroy can do for you. In the case of this particular application, all of these boxes are just processing text streams that are flowing between the swarms, right? They're regular expression matches. They are change the format of some text. They're put out constant text. Like the help command is really tough. No matter what it gets, if it sees /help, it puts out a message that says your valid commands are this. Right, so you can have hardwired text that goes in as prompt, parameterized text. There's a lot of different ways to use it. But the point is, in 30 minutes this morning, we had collaborative workspace plan sharing.
Yeah, and the beauty of this is that you could create a private swarm that's for all of your tasks and your schedules, right? And then if you could set this up so that the swarms are talking to each other, and you could tag specific tasks as today, and then have the ability to read them into the plans and automate from your task list and your schedule what's in the plans for everyone else to see, right? So, I mean, there's a million ways to use these.
And there's a block over here that we haven't shown that's really not very exciting when you look at it. It's called Opener. But what that does is open deep link URLs in your local operating system, which means these LLMs can send messages to applications like your calendaring app, or your desktop instant messaging app, or your web browser, or talk to any application that has scriptable capabilities depending on your OS. For instance, in Mac OS, it's very, very easy to use this block to run shortcuts. So you can have shortcuts that do, image cropping and rotating, or, turning on lights in your house or whatever. And these swarms can talk to it and get results back, because there's a way for the things that you deep link to in the operating system to talk back to Kilroy with their results. So,
yeah, it's fantastic. I haven't done enough with Opener yet. I need to play with that some more, because it's opens a whole lot of possibilities.
Oh, that's so bad. Well, anyway, that's what we made today. And we really want other people to be able to make these sorts of things too. So, paid Kilroy advertisement. If you want to play with this thing, get involved, be an early stage developer in it, participate in this project before it blows up, send Brad a DM on Twitter.
Yeah, you guys can DM me at B05 Crypto on Twitter, B05 on Farcaster, B05 Crypto on Telegram. We're looking for folks that are doing research and want to work in it. We're looking for folks that just want to build things and try it. And I can tell you that the folks who come in early are going to see potential upside from being an early contributor, an early contributor to the Kilroy ecosystem, building pipelines, doing referrals, helping us with marketing, coming up with
Even just
module
being
ideas.
in a chat room, right?
Yep.
Helping other people.
Yeah, participating, helping, writing up documentation tutorials, whatever you think you could bring to the table, we probably need it. But what we need most is people using the application and building in it and running into the things that we haven't thought of yet. And that's really where we are now. And we also need developers that want to build integrations and modules. If you have a DeFi protocol, you have a Farcaster app, we would love to integrate those, and we're very interested in being tightly integrated with the Farcaster community as well. So please do not hesitate to reach out to me, B05 on Farcaster and B05 Crypto everywhere else. Yeah, that's great. Anything else, Chuck?
Well, I mean, if they can't get you, they could get me at C Shotton just about everywhere else.
Yep.
But no, I think that's it for today. I'm going to go play with this thing some more.
Beautiful. Well, thanks, man. I love this thing. I'm going to play with it too, and probably be distracted and not get anything on my plans this time.
No, as according to your plan, you have some calls to make.
Yeah, exactly. All right. Thanks, man. Everybody have a great day. Thanks for paying attention. Thanks for watching. And if you have any thoughts, feedback, ideas, or you want to participate, please don't hesitate to reach out to me. Thanks.
Later.
Bye-bye.